All right, hello, Mr. Beelan here, following up with another science video about chemical reactions. This time we're talking about rates and energy. Okay, so chemical reactions involve the transfer of energy, right? Nothing can happen unless there's some sort of energy transferred around. So we have two different types of ways to transfer energy in a chemical reaction, okay? So we have exothermic reactions and we have endothermic reactions. And this has to do with the heat that is given off or taken by the reaction, okay? So let's look at the roots of these words, right? So thermic, that's where the heat is involved. That's how we know it's a heat-based reaction. And then we have exo and endo. Now exo, right, your exoskeleton or exterior, right? So this usually means out, right? Whereas endo kind of sounds like in, right? So in. So an exothermic reaction is when heat is given off in a reaction. Okay, so this is when you're combining, say, two chemicals and then the test tube starts to get really hot, right? There is an exothermic reaction happening there. A good example would be fireworks, okay? So in fireworks, there are some metals combined together that cause a reaction, that cause an explosion. There is heat given off and light. So that would be an exothermic reaction. An endothermic reaction is when heat is absorbed in a reaction, okay? So this is when the reaction actually causes it to be a little bit colder because it is sucking in heat. So an example here is using chemical ice packs, right? So they come in dry and you crack them and then they start to become cold, right? Because they're absorbing all of the heat and in turn it makes it feel cold. Another example actually of an endothermic reaction is photosynthesis, right? It is plants are taking in heat or light, right? It is an endothermic reaction. So to go with reactions, there are ways to speed up and slow down reactions besides just looking at the heat. What we have here are two things called catalysts and inhibitors. Now, catalysts and inhibitors are unique in that you can include them in a reaction, but then they won't change the reaction. They will just change how fast the reaction is happening. So a catalyst is an element that speeds up a reaction without changing it. Now, if you can think of any sort of catalyst here, maybe write it down. One example is actually inside cars. We have something called a catalytic converter. Okay, the word's right in there, catalyst. And a catalytic converter, what it is actually a piece of platinum. And the platinum is used as a catalyst to turn carbon monoxide gas into carbon dioxide gas, which is much less dangerous, right? So that is what the catalytic converter does, and that's why it's super important that you have one in your car so that you don't end up with any sort of noxious fumes building up with carbon monoxide, right? So, for example, again, a catalytic converter. All right, an inhibitor goes the other way. So an inhibitor slows down a reaction without changing it. And that makes sense from the word, right? It inhibits, it restricts something. So inhibitors come up actually a lot in biochemistry. They are involved with slowing down those types of reactions. It comes up actually quite a bit. One good example is aspirin. Aspirin serves as an inhibitor when it's ingested, right? So that is basically it for this video, right? We have different types of reactions, some where heat's given off, some where heat is absorbed, and then two different ways to influence the speed of the reaction. It's just a little bit of extra information I want you to write down, include in your notes. But this is important stuff going into chemistry next year and the year after, okay? That's it. Take care.